Welcome. My name is Josh Almeida, and I am very excited to bring to you our latest installment of Focus on Learning, brought to you by New Bedford Public Schools and New Bedford Cable Network. While the best way to find out what your child could be doing at home is to work directly with your child's teacher in school, we know these videos will help everyone keep learning active at home.
Hello, this is Mrs. Guy from the Ashley Elementary School. I teach grade 4 there. And today we're going to be doing multiplying fractions with whole numbers. We're actually going to do some pages out of your packet number 3 that recently came to you. Hopefully you got it. I know that the schools were handing them out, and I'm hoping that you got the 3rd packet, which hopefully, if I understand correctly, is the last one you're going to have to do before the end of the school year. Yoo-hoo! I have pulled pages 515 and page 2 of the center activities. I'll show you the pictures of those so that if you need to hunt them out while I'm doing the review, you can do that now. Alrighty? So we have page 515, and page 515 here has tomatoes on it. Alrighty, so find that page. We're going to do the questions on that one, and then we're also going to do the angles and circles, because believe it or not, this is actually a multiplying fractions worksheet. It doesn't say that, but you know how those grown-ups are. They're trying to trick our smarty pants kids, and we're not going to let them. So we're going to have those 2 worksheet papers, and you can find those in your 2 packets while I'm doing the review, because as I said, the lesson is multiplying a fraction with a whole number. But I want to start with multiplying 2 fractions together so that you don't get saying, oh, geez, how do you do that? We're going to just do a quick review right now. Alrighty? So on the Elmo, I have 2/3 times 1/2. And the best part about multiplying fractions is all you're doing is numerator times numerator over denominator times denominator. And in this case, we're going to have 2 times 1 is 2, and 3 times 2 is 6. So it's really cool. It doesn't matter. You don't have to have the same denominators. The numerator can be greater than the denominator. There's nothing. Multiplying fraction, probably the easiest thing to do with fractions in my opinion anyway. So 2/3 times 1/2 is 2/6, because 2 times 1 is 2, 3 times 2 is 6. Now I know that 2/6, they have a common factor. 2/6 can be divided by, and of course you always want to do the most reduced form of your fractions. Unless the answer is there in not a reduced form, you always want to do the reduced form. Teachers are fussy like that. So let's do 2 and 6 both can be divided by 2. So we're going to do that. We're going to divide by 2/2, which is really nothing more than saying divide by 1, because remember, 2/2 is equal to 1. 2 divided by 2 is 1, and 6 divided by 2 is 3. And so our real answer for this one is 2/3 times 1/2 is actually 1/3. Right? And that's just a review of multiplying 2 fractions together. So now, squiggle wiggle and move on to multiplying by a whole number. And actually, we're going to turn that whole number into a fraction. And I'm not sure if everybody got this from their grown-up, but every whole number has a secret denominator. And it will always be 1. So if I were to give this example 5 times 1/2, I actually am going to turn that 5 into a fraction by putting that hidden denominator of 1 underneath it and multiplying by the other fraction that's already listed there. Because, now think about this, be logical. 5 divided by 1 is 5, yes? And that's what we're starting with. That number 5 if I put a 1 underneath it, it does not change that it's still 5. And that's why I like that 1, man. It's such a universal number. They actually call 1 a universal number because they're being used so many different ways. 1 equals 2 halves, 3/3, 4/4, 5/5, 6/6, and so on until infinity over infinity. And here, 1 is actually just waiting for a whole number to turn itself into a fraction. So now, straightforward, we're just going to multiply just as we did up here. We're going to do the same thing here. Numerator times numerator. 5 times 1 over 1 times 2, or 5 halves. Because 5 times 1 is 5, 1 times 2 is 2. Now again, this is an improper fraction. We don't want to do that. And I know that there are 2 hidden whole numbers in there. I'm going to do it the slow way. I'm going to subtract 2 halves. By subtracting 2 halves, I'm going to add 1 whole number to it. And then I'm going to subtract another 2 halves and add 1 whole number. And this whole thing turns into that there is 1 half left here, and there are 2 wholes here. And our answer would be 2 and 1 half. Alrighty? So that's just the basic calculation of multiplying a whole number by a fraction. Whatever that whole number is, put 1 as the denominator, and now it's a fraction, 5 over 1 or 16 over 1, and then multiply it by the fraction that they've given it to you. So now let's put that into use. Let's practice that. Let's take a look at number 5 on the packet that we were given. On page 515, number 5 is asking us to find the products to complete the table. So we're going to do this 4 times. We're going to take that 3 times 4 6. We'll do it right over here. 3 times 4 6. Let me zoom in a little bit better. And that's the same as saying 3 over 1 times 4 over 6. And in 4th grade, we don't really talk about the cross-canceling, so I'm not going to do that today. I just want to be straightforward, numerator times numerator over denominator times denominator. 3 times 4 is 12. 1 times 6 is 6. And guess what, my loves? 12 sixths is the same as 12 divided by 6. That equals 2. So the product of our first one is 2. Isn't that funny how this can turn into that? I like that. And I also know the logic of this. I'm taking 3 and I'm multiplying it by something less than 1. My answer better be something less than 3. And in this case, I'm going to be taking 2 and multiplying it by something less than 1. So my answer better be less than 1, less than 2. All right, well, let's prove that. 2 times 4/5 is 2 over 1 times 4 over 5. And we're doing the same exact thing. I'm going to do a little squiggle wiggle so I can separate. 2 times 4 is 8. 1 times 5 is 5. And I already can see that I have a hidden whole number in there. Whole number is a numerator over denominator, and the numbers are the same. And if I subtract a fraction version of a whole number, I'm going to add the whole number version of a whole number. 8 minus 5 is 3/5. And the 1 whole number. So that is what we're going to put into the box for the product of number 5, 2 times 4/5. I might have gone a little bit fast on that one. So just a quickie. When we got the 2 times 4, and it became 8, the 1 times 5, 5. When I subtracted that 5/5, I know that 5/5 equals 1. So when I take that 1, there's the 1 of the whole number in the answer, and 8/5 minus 5/5 is 3/5. So that when I took that 5/5 away, I still had 3/5 left. And that's how we get that answer, 1 and 3/5. Now let's go put that into our box. And the next one is 5 times 2/3. I'm going to do a little squiggle wiggle so I don't get confused. 5 times 2/3 is the same thing. We're going to add a 1 in the denominator of 5, because remember, 5 divided by 1 is 5. We're still dealing with that number 5, but now it's in fraction form. That makes our lives easier. 5 times 2 is 10. 1 times 3 is 3. 10/3, that's again an improper fraction. I can do, I'm going to do it the other way that we know how to do it. I'm going to do 10 divided by 3 over here. Nothing there. I can get 3 of them. Taking 9 away leaves me 1. So my remainder of 1 becomes 3 is my whole number, and I have 1 of those thirds left over. So this is 3 and 1/3 for turning 10/3 into a mixed number. 3 and 1/3. Okay. Last one in this section. 2 times 3/6. 2 times 3/6. Again, I'm going to add my 1 as a denominator, not changing the value of 2, but just changing the look of it. 3/6. That is, this one's easy peasy lemon squeezy. 2 times 3 is 6, right? And 1 times 6 is 6. Ding, 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 1. 6 over 6 is 1. And 1 will be our number. And again, I want to go back to the logic of this. When you multiply a number by a fraction that is less than 1, your answer has to be less than the whole number you started with. So 3 times something less than 1 is definitely a number less than 3. 2 times something less than 1 is definitely a number less than 2. 5 times a fraction that is less than 1 comes up to a number that is less than 5. And 2 times a fraction less than 1 is a number less than the original 2 that we started with. Excellent. All right, so that's pretty straightforward stuff. This next one is going to be a word problem, so we're going to add a little, fluff to it. You have to like dig out all the gold that's in these sentences so that we can do our calculation. Alrighty? So we're going to move right to number 6. Morgan, am I on that? There we go. Whoa, you gotta zoom out so we can see everything. There we go. Morgan buys 6 tomatoes. 6 tomatoes, I don't want to lose that label. That each weigh 1/4 of a pound. So that's 6 tomatoes at 1/4 pound each. And then Russ buys 14 tomatoes that each weigh 1/8 of a pound. So this is Morgan, and here's Russ. He's got 14 tomatoes at 1/8 of a pound each. So now at this point I stop and I don't want to read the next sentence because I wanted to get my mind going. They said 6 tomatoes at 1/4 pound each and 14 tomatoes at 1/8 pound each. What could they possibly ask me? They could ask, how much do all of the tomatoes the 2 of them bought weigh? They could ask how much more, or they could ask which one has the greater amount of pounds of tomatoes, or they could say how much more is one than the other. Yeah, they could do those 3 things. Well, let's find out, because now we have in our head the 3 things that's possible to do. Let's find out what they actually want us to do. Who buys tomatoes that weigh more? Alrighty, and again, that powerful sentence, show your work. So they want to know who weighs more. And to me, that's the greater of the calculation answers. So we need to do both of these as calculations. So let's do 6 tomatoes times 1/4 first, and then we'll do 14 tomatoes times 1/8 next. Alrighty, 6 times 4 is saying the same thing. And here, I'm actually not going to do a new line because I'm such a smarty pants about this. And you can be also. I'm going to just add the 1 as the denominator, and I'm going to do 6 times 1 is 6, and 1 times 4 is 4. That's an improper fraction. So 6/4, that leaves me, I'm going to do that down here, 6/4 minus 4/4, which is a hidden whole number. I'm going to take the fraction version out, and I'm going to add the whole number version in to get 1 and 2/4. 6 minus 4 is 2, and I have the whole number. Alrighty, so I've got 1 and 2/4. Now I can reduce that. I'm not sure that I have to, but I'm going to do it anyway. 2/4 is also the same as saying 1 and 1/2. Now I'm going to do the 14 times 1/8. I'll do the same thing I did here. 14 over 1 times 1 over 8 is 14 times 1 is 14. 1 times 8 is 8. And 14/8, again, another improper fraction. And I keep saying improper fraction. Oops, I'm touching things here. I keep saying improper fraction. I shouldn't presume that you remember what that was. Improper fraction, again, is when the numerator of a fraction is greater than the denominator of the fraction. So the number at the top, the numerator, has a greater value than the denominator. And if we look at 14/8, we can see that 14 is absolutely greater than 8. So now I know that I can subtract that hidden whole number in fraction form, add a real whole number in whole number form, and then I can do 14 minus 8 is 6, plus that 1 whole. 14 minus 8 is 6, and eighths are eighths. So 1 and 6/8. Again, I can reduce that. So now these guys both share a factor of 2. So I'm going to equaling the 1, and then take that 6/8 to the side, divide it by 2. Whoops. Divide it by 2/2 to get 3/4. So I really have 1 and 3/4. So now I've got to compare those and see. Did a little bit of extra work that I actually didn't have to, because now I'm going to compare them, and I really am not going to use that 1 and 1/2 that I had reduced the 1 and 2/4 to, because the other version, the other fraction mixed number I'm going to compare is 1 and 3/4, and I can't reduce that to halves. So I'm going to go back and I'm going to see that 1 and 2/4 here, 1 and 2/4, and 1 and 3/4. Well, easy peasy lemon squeezy, right? 2/4 is greater than 3/4, so I'm going to have that number greater. Now, the trick is, don't forget who did this one. So I'm going to track this one back.
Hold on. You said 1 and 2/4 is greater than 1 and 3/4.
Oh, it isn't. We know that's not true. Hey, can I fix this thing on here? What did I touch?
I don't know what you touched. It doesn't bother me. It's not bothering anything if you just say that line again about
Sure.
2/4. So you have 1 and 2/4.
Yep.
I'll show you because that's already written.
Ready?
Yeah.
So now I have 1 and 2/4, which, and when we compare 1 and 2/4 and 1 and 3/4, 2/4 is less than 3/4, which means the 1 and 2/4 is less than the 1 and 3/4. So the question they ask, though, who buys tomatoes that weigh more? Well, that 1 and 3/4, we've got to track back to what it originally came from, and it came from 14 times 1/8. And that's this calculation, and that is Russ. So we're going to answer Russ buys tomatoes that weigh more. So on that line, I'm going to write Russ buys tomatoes that weigh more. And I'm going to square this up because I have my kiddos square their answer so that they can show me they know what they're talking about. And now I can prove that 1 3/4 is Russ. All right? And that is how you do this particular question. Alrighty. Now I'm going to move to the next page, the angles and circles. And it is saying on this, pretty straightforward, but you're going to see how it turns into multiplying fractions. Alrighty? And we're at, and again, I have a page 2 here, but it's in the activity center. So let's take a look at this one, and I'll do a couple of these. And then I'll leave the rest to you because, I want you to show how smart you are. So I'm looking at this first one, I'm looking at this circle, and they're saying this fraction, so almost as if I were shading that in, 1 of the 4 is shaded, so to me that's 1/4, which turns out to be 1/4 of a circle, and every circle has 360 degrees, so now I'm going to find out how many, so now it's 1/4 of 360, and again we're just doing that multiplying fractions, and I've got to use some math paper because there's not enough room here. This says 1/4 of 360 degrees, and that's the same as saying 1/4 times 360. So 1/4 times 360, and again that's a whole number, but we want to turn it into a fraction so that we get 360 over 4. And now I've got to do some division. Gosh, we're doing a whole bunch of different things on this one. I like that. 360, and we'll divide by 4. And if you saw the division program, we're going to go shopping with Mrs. Guy. I have 4. I have 3 in my wallet, but they cost 4. I cannot buy any, so I'm going to put 0 on the counter to be paid. Since I didn't buy anything, I don't have to pay anything, but now I'm going to get more money out of my wallet. Now I have 36, and they cost 4. 4 times 9 is 36, so I'm going to put 9 items on the counter. 9 times 4 is 36. I'm not going to get any change back, but don't forget, for every number in the house, you have to have a number on the counter. Alrighty, so let's bring that 0 down to help, but it actually doesn't help because I still have 0 money and I can only buy 0 items. So 360 divided by 4 is 90 degrees. So now we go back to that input page and we'll put 90 degrees. There you go. All right, so now the next one is they're saying they want to know about this part. And I can see that this circle is divided into 3 equal pieces. So I already know the denominator is going to be 3 because of the total number of sections. And I see that 2 of them are shaded in. So I'm going to do 2/3 of the circle and 2/3 of 360 degrees. And we'll go back to the math paper because there's just not enough room to do this work. 2/3 of 360. We'll be more efficient this time. We'll just add that denominator right away. And 2 times 36 is 72. Add that 0. And 3 times 1 is 3. So now I've got to go back and do a little bit of division. 720 divided by 3. And again, I only take money out of my wallet that I need. Here I have 7. The items cost 3. I can buy 2 of them. 2 items times $3 each equals 6 that I'd have to pay. And the, whoops, I'm a little crowded there. And the change I get back from the cashier is 1. I then go into my wallet and I get the next number. Now I have 12 and the items cost 3. 3 times 4 is 12. I'm going to put 4 more items on that counter, pay for them because what you buy you have to pay for. 4 times 3 is 12. And again, no change. And I have 3 numbers in, I only have 2 numbers up. So I'm going to bring this last one down. Even though it doesn't help, I'm still going to do that work to make sure. And then I'm going to buy none, 0. So that this one is 240 degrees. So let's put that into the amount of degrees for that second one. 240 degrees. Alrighty, I think I'm going to leave the rest to you. You get a head start on this page, and I didn't do it all for you, so you can prove to your teachers how smart you are, even though you might have gotten a hand up from Mrs. Guy. That's okay. That's it for me today. Multiplying fractions with a whole number, and how easy peasy it can be. Alrighty, you guys be safe, be good, and be happy. Bye-bye from Mrs. Guy.